Welcome back to the GCSE Maths Pro YouTube channel. In this video, we will be looking at the most repeated EDEXCEL questions on graphs. So we're going to start off with some slightly easier ones and work our way through to the harder questions. And if you're interested in looking at the original questions or even the mark scheme, I will have all of the papers linked in the top right hand corner. So we've got question 4 here. We've got different parts. The first part is to complete the table of values for y equals x squared minus 2x plus 2. As you can see, there's only a couple of values missing and it is a calculator paper. They haven't actually given you any space for working either. So this is where I would assume I would use my calculator trick to fill out the rest of that table for me. So grabbing your calculator, it might look a little bit different to this, but if you type your calculator code into YouTube, you will likely find the specific instructions. But basically, it's something about one of these options at the top. Mine is called mode, yours might be called menu, something like that. Here I'm looking for the table number, which is in this case number 7. Sometimes I think it's number 3. It just depends. Then I've been shown f of x. Now f of x is the same thing as saying y. So f of x equals y equals. After that, you're going to type in whatever graph equation you have. So this is a quadratic, but it could be anything really. It could be a straight line, it could be a cubic, it doesn't matter. It works for all graphs. So just make sure you know where your x is on your calculator. Mine is down here. I have to press alpha in order to get to it. So x and then just squared as normal, minus 2, x again, plus 2. So that's the same equation that I have in the question. Equals. Now, sometimes they'll give you a second option if you wanted 2 lines, but I don't want that, so I'm just going to keep pressing equals. Then they will give you start. That means the start of your table. So, you could start at -1 because we've already got -2, but let's just go with -2. I just type it over the top. End is then obviously the other end of the table, which is 4. And the step means the difference between each column. So you can see here it's normally going to be 1. Now, the only thing is they will give you the table vertically instead of horizontally, but otherwise you can see we've got -2 for x, 10 for y. We already know that. But then the next one is -1, 5, 0, 2 they've told us, 1, 1 we need, 2, 2, 3, 5 they've told us, and 4, 10. So I can just literally write all of those digits in, and I don't need any working out. The other thing to note with a quadratic is it's always a U shape if it's positive, and that means there's a line of symmetry. So if you have a look at the y values, you can see that our line of symmetry is going to be at 1, isn't it? Do you see how it was 2, 5, 10, and then on the other side also 2, 5, 10. So you can also see if there's a line of symmetry there as well. And if you work out some of the values, it can maybe help you just fill in the rest of them in some cases. Part B, on the grid, draw the graph of y equals x squared minus 2x plus 2 for the values of x from -2 to 4. So basically just plot the table that you've just written out. So that bit's really easy, another nice and easy 2 marks. -1, 5. Just be careful of the scale because sometimes it's different on different axes. 0, 2, 1, 1, 2, 2, and you can see it should be going back up again. 3, 5, 4, 10. So as I said, you should be getting some kind of U shape because it's a positive quadratic. So you know, yeah, I probably got my coordinates correct because that is creating U shape. Obviously, use your pencil to do it just in case you need to rub it out, but you should be doing as smooth a curve as possible. So something a little bit like that. Now, part C is where it gets a little bit trickier. Use your graph to find estimates of the solutions of the equation x squared minus 2x plus 2 equals 4. Now, I don't know if you can see, but this left-hand side is the same as the original equation. So the only thing that's changed is originally it said y on the other side, now it says 4. So you might naturally want to rearrange it. There's 2 reasons why we won't do that. 1, do you see how again they've not given you really any space for working out, just enough space to write your answers down. And 2, it's because what that means is that we're looking on the graph, because I said to use the graph, at where y is 4. Most of the time it will equal to 0, and that means you look at where y is 0, which is the x-axis. But sometimes, especially for higher tier, they might throw in a different number. In this case, it's 4, so I need to draw a quick line across at 4 and see where my curve crosses it. So you can see I've got roughly here and roughly here. Obviously, it's normally 2 solutions because it's a quadratic. And they've said estimates because we can only read it off really to 1 decimal place. It doesn't have to be as specific. whereas in reality, the solutions are probably loads of decimals. So here are my solutions. Yours might come out slightly differently because obviously it's quite hard to draw exactly the same curve for everyone. So they will give you a slight range of possible values. As long as you are within those ranges, you'll be fine. So mine's not drawn very accurately. Can you see how I've kind of missed that cross here? So I'm going to go with that being negative 0.8. So it's probably more so this way, isn't it, in reality? And for this one, it looks about 2.65, doesn't it? But just to be on decimal place, I'll put 2.7. So that's what I'm estimating. Negative 0.8 and 2.7. A lot of the time I do find that the decimal is the same. So negative 0.8 and 2.8 maybe. That's quite common as well. The range of possible values they've allowed for is negative 0.65 up until negative 0.8. So I was right on the edge there. And then 2.65 to 2.8. So I was right in the middle of that one. So as long as you've got something between these two values, obviously two solutions, then you will get those extra 2 marks at the end. So nice easy 6 marks I feel like there. We've now moved on to question 8. This is a straight line graph, but we've got actually a bit of a context to it. So an electricity company charges the same fixed amount for each unit of electricity used. David uses this graph to work out the total cost of the electricity he has used. Part A is to work out the gradient of the straight line. So just gradient of any straight line, don't need to worry about the context here. That's the change in y over the change in x. So let me choose 2 quite nice coordinates. Try and find some that you think, oh yeah, that's quite a decent coordinate. I'm looking maybe here. Just be careful that you read it off. That's obviously at 40, and then in terms of the scale, that would be 6, wouldn't it? So 5.5 for y and 40 for x. And then another one, I could do this one maybe, 20. Oh, you could obviously even do 0. Actually, yeah, we could even do 0, 0. Might as well do that. That's a bit easier, isn't it? So change in y over change in x. We've got 5.5, technically minus 0. I know it doesn't make any difference, but just to give you the method marks. Then change in x, 40 minus 0. This one's obviously a calculated question. So I've got here 0.1375. I'm just going to write down all of those digits because it's not that many. Now they've said they will allow anything from 0.135 to 0.145, and that's just because even though it's an exact line, the coordinates are kind of a little bit difficult to interpret and read, aren't they? They're quite small, so anything between here is fine. And then the part B is then, what does the gradient of this line represent for 1 mark? Now they've got a lot of different options for the answer, but their main answer is the cost. So you can see from the y-axis, per is another way of saying like divided, isn't it? If you think about it, the y divided by the x, cost per unit of electricity, because that was the original context, wasn't it? Per unit of electricity. That's the main answer they've given you. Now they will allow other options as well, as long as you've given the context and you're making a reference to this rate of change. You could say the rate of change of cost with units of electricity. You could say each unit costs effectively 14p, doesn't it? The cost of each unit of electricity, anything like that is fine, but quite an easy one to get 3 marks there. Question 14, I've seen quite often that they will give you a variety of graphs and ask you to match them up with the equations. So here we've got 9 graphs, but in the table we are asked to match it with only 4 equations. So you have to know which ones are basically not relevant. So we've got a trigonometric graph, we've got a cubic, we've got an exponential graph and a reciprocal graph here. But if you have a look, we've got so many graphs that actually some of them are kind of the same, but maybe a negative version of the graph, or they're very similar. So you have to really be happy that you know exactly what each of them are. This one here, that's an exponential graph, isn't it? But if you look at I, it also looks like an exponential. So it's not just going, yeah, I know roughly what an exponential is. It's knowing specifically which one goes up and which one goes down. Now, for ours, we've got that the value is 2, which is greater than 1. So that one is A, it goes up. The exponential graph is any value, any number to the power of x, but specifically when it goes up is when k is greater than 1. When it goes down, it's not necessarily negative, it's just when it's between 0 and 1. So that is still to the power of x, but it's when k is 0 point something. So not necessarily negative. The next one is a reciprocal graph, but again, can you see how h also looks like a reciprocal graph? So you have to figure out which one matches 4 over x. H is the one that matches it. So this is where we have, again, a number k over x, but specifically that's the positive one. That's where k is greater than 0, it's a positive, so 4 is positive. This one is also k over x, but that one would be the negative version of the graph. Now C, this looks like a trig graph, but then also so does D. We've got here sine x. So you have to remember specifically which one is sine, and obviously which one is cosine. They both look very similar. I always remembered that sine starts at 0, 0, which is clearly C. And cosine starts at 1, which is D. E is a positive quadratic, but none of these are quadratics. So that's a positive x squared graph. And then G is a negative x squared graph. So we don't need either of those. And then it leaves us with just one left, which does happen to be not just a cubic graph, but a positive cubic graph. The negative cubic graph would be the other way around. That one would be negative x cubed. So there you are. Got different graphs. This one is F. And there's your 3 marks. So you should be able to recognise all of these graphs, but ideally if you can go the extra mile and pick apart positive versions and negative versions as well. So the next one, question 16. The straight line L has the equation 3y equals 4x plus 7. The point A has coordinates 3 minus 5. Find an equation of the straight line that is perpendicular to L and passes through A. So this is an ideal perpendicular lines question. 3 marks, we just need to work out the gradient of the perpendicular line, which is the m, and the y-intercept. We always need to work out the gradient first, so we need to compare it with the gradient of line L. But obviously right now, this is the only thing, be aware that this 4 is not the gradient, just because it's currently 3y, not just y. We need to make sure that y is the subject of any straight line equation if you want to look at the coefficient of x and take it as the gradient. So my first step is I'm going to divide the whole equation by 3. Now obviously that's not whole numbers, so I'm going to leave it as a fraction. 4/3 x plus 7/3. Now the plus c is kind of irrelevant for this. We're just looking at the gradient. The gradient of line L is positive 4/3. In order to find the perpendicular gradient, so let's call it P, I need to do the negative reciprocal. So first of all, it's already positive, so I need to make it negative. And the reciprocal is where you flip the fraction upside down, so 3/4. So now I have my gradient for the perpendicular line. Let's write that in. Negative 3/4 x. The only thing missing is then the y-intercept for the perpendicular line. Now, because I've used this piece of information, the only thing left is point A. Why have I been given point A? Well, I'm going to use that to find out the y-intercept, because I know that this line goes through point A. So substitute in the values, just make sure that you don't get them the wrong way around, because obviously 3 is x and minus 5 is y, so just make sure to write those the correct way around. Times 3. Do you see how now I'm just left with an equation with some obviously numbers and then c? So just rearrange this and solve it for c. You can obviously use your calculator if you want to. When I rearrange it, I get c as negative 11/4. I've left it again as a fraction. Once you've done those two things, the gradient and the y-intercept, we just have to write it together in the full equation. So y is equal to negative 3/4 x minus 11/4, or you could put it in the decimal format as well, that's fine. And that is 3 marks. So a really nice straightforward perpendicular lines question there. The next 2 questions are on solving simultaneous equations graphically, so this one's a little bit easier again, but then the other question after this will be a little bit harder. So the graphs with equations 3y plus 2x equals 1/2 and 2y minus 3x is equal to negative 113/12 have been drawn on the grid below, so I've drawn it here. Using the graphs, find estimates of the solutions of the simultaneous equations. So the solutions of simultaneous equations, particularly here where they're both linear, they're both straight line graphs, aren't they? We're going to have one x and one y solution. And for simultaneous equations, it's where they're both the same. So the same x for both lines and the same y for both lines. Where might that be on the graph? Well, that's likely to be where they intersect, where they cross over. That's where they share the same x coordinate and the same y coordinate. And hence why there's only one solution, because they only cross once. So let's read those off. It says an estimate because obviously the actual decimal is quite hard to pick out, so give it to either 1 or if you can maybe 2 decimal places, but 1 should be fine. I think I would probably stick that, let's just check the scale, at maybe 2.25. Yeah, I think it's quite obvious that it is halfway between, isn't it? So I would go with the extra decimal place there. And for y, this one's also kind of, not quite halfway through really, but it is a little bit lower. So that's negative 1.123. You could go 1.3, 1.35. Now they have given a range of possible values because even though it's drawn accurately, it is kind of hard to read it off. So they've said for x, as long as you get anything between 2.2 to 2.3, so whether that's 1 decimal place or 2, that's fine as long as it's between those two. And for y, negative 1.3 to negative 1.4, so anything between those, or obviously including those two values as well, is fine. So really nice 2 marks there, just literally see where they cross. Now this is also simultaneous equations, but a harder question. We've already been given that the diagram shows the graph of x squared plus y squared is equal to 30.25, which is obviously a circle graph. Use the graph to find estimates for the solutions of the simultaneous equations. You can see again x squared plus y squared equals 30.25, but you can then see another equation, which is not on the graph, is it? It's not already there. So this is 3 marks because what we actually need to do is plot this graph first. So hopefully you can have a look at that equation and go, yeah, I know that's a straight line. Even though it's rearranged, I know it's a straight line. Now, the way I would plot a straight line is I wouldn't go through and work out all of these digits. There's no point, all of these coordinates, it would take too long. For straight lines, really, all you need to do is plot 2 coordinates and draw a line through it. So let's just rearrange it so we've got it in the format of y equals 2x plus 1. The easiest coordinate, I think, to plot is the y-intercept, isn't it? That's just the plus 1, so 0, 1. There's 1. Then I like to choose one a little bit further along, obviously not too far that it comes off the graph. Let's say when x is 3, I'll substitute it in and see what that makes y. So 2 times 3 plus 1, that makes it 7. So yeah, that just about fits on the graph. So there we go. And you see how if I get my ruler, I'll obviously extend the line the whole way through the graph. So there we go. That is my second equation. Now, we're trying to find out where they intersect, which obviously happens in 2 places. So we're going to have 2 solutions for x and 2 for y. So we can see up here and down here. So for x, that's just a little bit further along from 2, isn't it? It's about halfway there. So also double check the scale. Do you see how the scale is different to the previous one? I would go with that being 2.1. That's what I'm going to say, 2.1. And then the other x coordinate is just a little tiny bit beyond this line here. So maybe 2.8, 2.9? Let's go with 2.9. And then obviously y, 2 solutions for that. It's kind of halfway here, just above the 5, isn't it? So I would go same scale on the y-axis. I'd go 5.1. 5.1. Oh, also don't forget to put a negative when it's a negative. That one's negative 2.9. And this will also be a negative y coordinate. So that is 4.2, 4.4, 4.6, 4.7, negative 4.7. There we go. So those would be the solutions I would put, but you see how we've got 2 of each now, not just 1. So these are the actual suggested solutions, but they have allowed a 0.2 range. So for example, you could get 5.0 to 5.2. So anything 0.1 less or 0.1 more than what I've written here is also fine. Okay, our last question, and I guess technically the hardest, is now on circle graphs. So the centre of a circle is the point with coordinates -1, 3. The point A with coordinate 6, 8 lies on the circle, so like on the circumference. Find an equation of the tangent to the circle at A. And they have also said to give your answer in the form ax plus by plus c equals 0, where a, b and c are integers. So the equation of a tangent is actually quite easy because it's basically just loads of different things you already know put into one question. Now you can always sketch it if you find that that's helpful to visualize it, but you don't have to. So let's say the centre is minus 1, 3, so maybe about here. That's the centre, and they've said the circumference goes through 6, 8, I guess over here. Maybe something like that. So they want the tangent there. They want this line here. So the equation of a straight line, obviously they've given it a different format, but basically is in this format here, isn't it? Y equals mx plus c, which tells us we need to know the gradient and where it crosses the y-axis, the y-intercept. We always normally try and find the gradient first, so how do we find the gradient when we don't have two sets of coordinates for the line? We only know one set of coordinates, don't we? That's why they've given us the centre. The centre of the circle is minus 1, 3, and if it is 0, 0 in other questions, you can also use that. I can use those two sets of coordinates, because one's in the centre, one's touching the circumference, to find the gradient of the radius. That's the radius there, that dashed line, isn't it? That's the radius. I could find the gradient of the radius by doing change in y over change in x. And I can also see, because my drawing is roughly accurate, that my radius gradient should be positive, and my actual tangent gradient should be negative, so that gives me 5 over 7. I would probably just leave it as a fraction. Now that's for the radius though. How do I link the radius to the tangent? If you think about circle theorems, there's a circle theorem that tells us that the radius to the tangent is always 90 degrees, it's perpendicular. So now let's go back to when we were doing the perpendicular line question. How do I convert the gradient of the radius into the perpendicular gradient for the tangent? Well, that's the negative reciprocal, isn't it? So it's already positive, make it negative, and flip the fraction upside down, which is why I say leave it as a fraction. So the gradient of my tangent is now negative 7/5. So we're halfway there. We've actually done the hardest bit now, because now we know the gradient of the tangent is negative 7/5 x. The only thing missing is the plus c, the y-intercept. Where does it cross the y-axis? I can see it's obviously quite a big number, but where is it exactly? Now that means I need to substitute in a set of coordinates that are on the line on the tangent, which is point A. So I'm going to substitute in 8 and 6, remember to swap them around, because y is first in the equation but not first listed in the coordinates. And then you can solve this. Now be aware that this is a non-calculator question though, so don't just think, oh, I'll just type that fraction into the calculator. Make sure you do know how to work out the fractions in this case, just in case it comes up in paper 1. So what I would do is obviously multiply the whole number by the numerator, 42 over 5. So that's not really simplified, is it? 42 over 5. What you'd have to do is then make 8 something over 5. So that would be 40 over 5, wouldn't it? If you simplify that, you get 8. Now I would obviously add 42 over 5, so that would give me 82 over 5, which also still doesn't simplify, so leave it as a fraction, as my plus c. Now if you do want to know what number it is actually 16.4, so you can see we knew it was going to be quite a large number, didn't we? So that does make sense. And then we just write it out fully. So we've got y is equal to negative 7/5 x plus 82 over 5. Do you see how they also both have 5 as a denominator? So that's quite handy, because we do actually have, in this particular case, one more step. I need to rewrite it in this format here, where not only can you see that everything is on one side, whereas here we've got it split, but also can you see that they've said that a, b and c, so the coefficients, are integers, they are whole numbers, which is why I mentioned about the fact that we have the same denominator 5. So first of all, I'd probably move everything to one side. So let's say we put x first, so add 7/5 x plus y minus 82 over 5. It's okay if one's a negative, that's absolutely fine, as long as they're all on one side, and then obviously they need to be whole numbers. So how do I make these whole numbers? Well, because they have the same denominator, just multiply the whole equation by that denominator. So I'm left with 7x plus, obviously then 5y, minus 82 is equal to 0. Now that's the format that they were asking for, so that would be my final answer. So we're just putting in a lot of straight lines, a little bit of knowledge about perpendicular lines and circle theorems, and then just rearranging at the end. Individually, it's not really anything really that complicated, but putting it all together is why this is now a question 20. So that is everything on the most common EDEXCEL questions on graphs. If you found this video helpful, make sure to like and subscribe, and leave down below any questions or comments you might have.